Greetings, math fans. All right, so this is day 2, and basically what we're going to do is we're going to kind of continue on with more arithmetic sequences and series. So let me just label this as day 2, more arithmetic sequences and series. So remember, a sequence is a list of numbers, and a series is the sum of those numbers. Okay? So let's just do a nice little friendly example here. You're given 5, 7, 9, and I tell you that the sum of all these numbers is equal to 60. And my question is, find the number of terms. So basically you're looking for n. Okay? So, we set this up. We have our nice formula, right? S of n is equal to 60. And that's equal to, remember, the average of the extremes. So we're going to say 5 plus, we don't know that last term, a sub n over 2 times n. Right? And just remember, we could substitute a sub n. We know that a sub n is equal to a sub 1, which is 5, plus d, we know that's 2, times n minus 1. So you get a sub n is equal to 2n, and that's going to be plus 3. Okay? So now what we can do with this is we can actually substitute this back into there for a sub n, and we wind up getting 60 equals 5 plus 2n plus 3 over 2 times n. Simplify that a little bit. 60 equals 2n plus 8 over 2 times n. Multiply both sides by 2, so I get 120 is equal to, and then distribute that n, right? So I get 2n squared plus 8n. Well, I see this is a quadratic right away, so I'm going to move that 120 over. So let me just kind of move down here a little bit. I get 2n squared plus 8n minus 120 equals 0. Now this is not too bad to factor. Obviously we can divide everything by 2. And we get n squared plus 4n minus 60 equals 0. And if I factor that, it's n and n. And we get plus 10 and minus 6, right? It's going to give us a 4n. And so we wind up getting n is equal to negative 10 and n equals 6. So here's the deal, math fans. We only have one answer for this. Only one answer. Okay, our answer has to be a natural number. In other words, you can't have the 0th term, you can't have a negative term, you can't have the 1.6th term. Okay, so remember, a natural number. So n is a natural number, which means 1, 2, all the way up to whatever. So that's why n has got to equal 6. Okay? Let me just show you polysimult, because some of you guys may or may not know that. Here is what I want to factor. Now, it's not always, in fact, let's actually go with this guy right here. Let me highlight it. Right, let's go with this guy. If I want to factor that guy, and you can use your graphing calculator. So you should have something on your calculator called polysimult or polysimult 2. So let's actually pull that up. Just move it over a little bit. Okay, and so if you go to your apps, and you got all these apps here, now you can get to it real quickly and just hit alpha 8, right? Alpha for P, and then you see PLYSMLT2, or you might just have polysimult. So you cursor down there. If you don't have it, you need to get it from me, okay? Because it's a really handy thing to have for this. And it's also really handy to have it for your ACT. It really is, to be able to factor quickly. Okay, so let's just kind of show it here. Start here, poly root finder, so we're going to hit 1. So you can just you've hit enter, it's fine. And the order is the secondary polynomial because it's n squared. You could even do n cubed, n fourth, n fifth, etc. And you can have it give it to decimal or fraction. So we're going to kind of leave it as fraction there. And hit next. So that's a graph, right? These are the main keys here. So anyway, you hit next. And then it lets you put your coefficients in. So in this case, we're going to put a 2 in there, hit enter, an 8 in there, hit enter, and a negative 120. And then you just hit solve. And voila, negative 10 and 6. There we go. Okay, and obviously you have to know which one to pick. So that's actually really, really handy to be able to do on your graphing calculator is polysimult. Okay, so let's just write that down there, right? Polysimult. And again, it might be 2 or it might be just regular polysimult. Okay, excellent. All right, so let's talk about something a little bit different than their arithmetic sequences of series. We're going to talk about something about, or it's called recursive sequences. Okay, they used to call it recursive sequences. I used to get a nickel every time somebody would use it, and then I lost my patent on it after so many years, and unfortunately now people don't have to pay me. Kind of a bummer. Anyway, recursive sequence is a sequence that uses previous terms to calculate future terms. Okay, so let me just explain here. If I said a sub n is my current term, a sub n minus 1 is the previous term. Right, these are subscripts, the n and the n minus 1. So it's the previous term, which is really the term before a sub n. And a sub n minus 2 is the term before a sub n minus 1, right? So it gives, if you do a sub n minus 3, it's one before that as well. Okay? So let's do an example right away here. And if I tell you a sub 1 is 5, and a sub 2 is 10, and a sub 3 is 15, and a sub 4 is 20. If a sub n, which is my current term, equals 20, or a sub 4 equals 20, right? Then a sub n minus 1, it's just the term before, right? So it's real easy. So I'm just trying to show you here. If that's my current term, if I'm on a sub 4 and it's 20, what's the term before it? A sub n minus 1 is 15. And a sub n minus 2 is the one before that, which is 10. Okay? Pretty straightforward. Okay, so let's talk about how to define a recursive sequence. So to define a recursive sequence, you need two things. Okay, the first one is you need to give me the first term. So I need a sub 1, and I'm going to make that 12. So I need the first term. First term. Okay, I'm going to put a star here. This is required. What happens a lot of times is kids forget that. They forget to give me the first term, and you got to start someplace, right? So there's only going to be one blank. If I ask you to define it and you don't give me the first term, you just give me the general term, you're going to lose a point. So you got to give me the first term, and then you have to give me the general term. A sub n equals a sub n minus 1 minus 2. So this is the formula. That's two things you have to give me. Again, the first term and then your general formula. Okay? And again, the way I'd read this equation here, I'm saying, hey, my current term is the previous term minus 2. That's the way you look at it. So my first example here, I'm going to ask you guys for this 1 and 2, the general term and the first term. I'm going to say find the next 3 terms. Well, that means you're going to say a sub 2 is a sub n minus 1, which means the previous term, which is 12, minus 2, which is 10. So you can look at it, a sub n minus 1 is the previous term, or literally if I put a 2 in where n is right here, if I put a 2 right there, 2 minus 1 is 1, so it's a sub 1. So a sub 2 is a sub 1 minus 2. Okay, but I like to look at it as, hey, it's the previous term. So then if I said a sub 3, it's the previous term, which is 10 minus 2, which is 8. A sub 4 is the previous term, minus 2, which is 6. So those are your next 3 terms. Okay, it's not too bad. Okay, so let's just do another one here because it's good practice. Find the next 3 terms given a sub 1, my first term is 20, and a sub n, the current term, equals twice the previous term, 2 times a sub n minus 1, plus 3. Okay, so it's easy. A sub 2 is 2 times the previous term, which is 20, plus 3. So that gives me 43. A sub 3 is 2 times the previous term, plus 3. So that gives me 89. And a sub 4 is 2 times the previous term, is 2 times 89, plus 3 is 181. Okay, those are your next 3 terms. Pretty easy. Okay, let's do something a little bit more aggressive. It says find the next 3 terms. And I'm going to tell you a sub 1 is 4. I'm going to tell you a sub 2 is 9. I'm giving you two terms here. Your equation, a sub n equals 2 times a sub n minus 1 minus a sub n minus 2. So remember, that's your current term. That's your previous term. And that's a sub n minus 2 is 2 terms ago. So the one before the previous term. Okay, that's why I've given you a sub 1 and a sub 2. So when I find a sub 3, okay, I can do a couple different things here. And but the way I truly want you to look at it is the third a sub 3 is the 2 times the previous term. Do you guys agree the previous term is 9 minus the term 2 terms before that? That's a sub 1 because it's 2 back from 3. So minus 4. So 18 minus 4 is 14. Now you can look at it that way, or I can say, watch this. I'm just going to do it all mathematically, just with numbers. A sub 3 is 2 times a sub 3 minus 1 minus a sub 3 minus 2. So it's 2 times a sub n, or a sub 2 minus a sub 1, which is exactly what I did here. 2 times a sub 2 minus a sub 1. Okay? But I like to look at it as the previous term or the one before that. So a sub 4 is equal to 2 times the previous term, which is 14, minus the one before that, which in this case now is 9. So I get 19 for that. And a sub 5 is 2 times the previous term, which is 19, minus one before that, and I get 24. And those are my next 3 terms. Okay, not bad. All right, so let's keep going here. Okay, so the next thing we're going to do is we're going to create recursive formulas. And general formulas. Which is your a sub n. Okay, so let's just start out with a nice little friendly example here. Given 5, 8, 11, 14, keeps going. Create a recursive formula. Well, again, it's really easy. Don't forget, you got to define the first variable. A sub 1 is 5. Gonna put a little star by that one. Kids always forget that. Okay, and then, well, the question you're asking yourselves is, what are you doing to that 5 to get to the 8? Well, do you guys agree I'm adding? I add 3. So I can say a sub n is the previous term plus 3. That's it. That's the answer to this. I just created a recursive formula. Now let's create a general term. A sub n. A little bit different. General term. So this is something, right? Basically, you know your value of d is equal to 3, right? Everybody agree with that? And my a sub 1 is 5. And so basically what I just need to do is kind of plug this in. It's a sub n equals a sub 1 plus d times n minus 1. Because you create a general term, which means you got an n in your equation. So it's kind of right up here. I get a sub n equals 5 plus 3n minus 3. And by the way, if you don't multiply it out, if you leave it like this, you put this as your final answer, you're going to lose 1 point. Because it's not as simplified as I wanted. You got to multiply that 3, distribute the 3, and then add the terms together, and a sub n comes out to be 3n plus 2. You don't need a first term for that because n always starts at 1. So literally, if I want to find a sub 1, it's 3 times 1 is 3 plus 2 is 5. And there it is. A sub 1 is 5. Okay? So that is your general term. No soluting required. A sub n equals 3n plus 2. And this guy right here is your recursive formula. Okay? Creating those are actually pretty easy. They really are. Especially, I think a sub n is actually really pretty easy. But all right, so let us do another example here. Given 2, 2, 4, 6, 10, 16, create a recursive formula. So what do you do first? Got to define that first variable. A sub 1 is 2. Well, let's actually, before we even start though, what am I doing here? What's going on? Well, is there something I'm adding to the 2 to get to the next 2? You know, if those numbers are the same, you got to think to yourself, gee, I bet you I've got to use, it's more than just adding numbers to it, because, I don't know, I'm adding 0 to 2, and then I'm adding 2, and then I'm adding another 2 and a 4. There's not really a pattern. So you kind of look a little bit broader and say, well, wait a second. If I add 2 plus 2, I get 4. And then if I add 2 plus 4, I get 6. And 4 plus 6, I get 10. And 6 plus 10, I get 16. Oh, I'm adding like the first and second term together. So that's what you're going to do. You're going to add the first and second term together. Well, I really need to define my first and second term then. So then when I say a sub n, it's the previous term plus the one before that. Right? I'm adding the 2 terms before to get my next term. And that's exactly what it is. So this is actually my recursive formula. Test it out. You know, so a sub 3 is 2 plus 2, 4. A sub 4, 2 previous terms, 2 plus 4, 6. A sub 5 is 4 plus 6, which is 10. All right? So let me just talk about this. There are basically, I'm going to put a little star here because there are 2 possible patterns for recursive. A sub n is actually pretty easy, right? It's just kind of looking to see, gee, is arithmetic and find the value of d, find a sub 1, and then kind of coming up with the formula. Recursive, a little more challenging, but I'm going to give you two little ideas here, two possible patterns. The first pattern is use the previous term and add or multiply by a constant. That's usually one of the patterns. Okay, and that's actually my first example that I did for recursive. Okay, the second is use the previous term and add or multiply by the one term before that. Okay, and this is just like my second example. So we're using a sub n minus 1 and a sub n minus 2. We're using actually two terms. Okay, as opposed to the first one, we're using one term and you're just multiplying or adding a constant. Okay, so that's kind of it, math fans, for day 2. Again, just to kind of recap a little bit, we did that one little friendly problem where you had to find value of n. Make sure you know how to do that. It's not that easy, but you can use your polysimult and just got to set it up correctly. And make sure you know how to, given the information for recursive, how to create one, or how to create the values, and also given the values, how to actually create a recursive formula and an nth term formula. Okay, I showed you both of those. So make sure you're good with that, and you should be good to go for day 2. All right, that's it, my fans. Have an outstanding day. Adios. Goodbye.